Hey Adam, it's us doing the CDSU this week.
Yeah.
Cool.
Have
I've
you,
got a little bit written down. I've also got a table if you want me to send you that.
oh yeah.
I think you guys could even
You
use
what I've got.
like who's doing the draft this week, or like the.
Sarah and I.
Okay. Do you want me to send you the table I have? I'm not sure if it'll help, but it's some form of table.
That'd be good. Thank you.
Is it a table? Is it a table of information though? Because that might, like ours is all just data collection.
Yeah, it technically is. I'll show you.
Can Adam or Nathan find the size? Just have the size of the sun ready as well, please.
Yeah,
Sure.
I'll move that to
I've got all the sizes in radiuses. Is that okay?
yeah, I think that's.
Thanks for the table. I'm not sure how we would discuss it much, though. I think that is more efficient than anything.
What data do you have on the second activity, Nathan? Did you see the message I sent you? Is it like that, or we got extra to add?
Oh, sorry. Is that the? Did you send me your?
Yeah, I sent you a private message on the little.
I think I have pretty similar information. I can send you mine.
Cool. Yeah, cool. You can because you could probably say your data, and then I could go onto mine and explain each planet. So that would work
Okay.
on activity 2.
Do you just want me to mention like each planet, and then you can kind of go into depth?
Yeah, you can basically just mention everything you've got in that what you sent me, because that's pretty good. And then after that, I'll just go through each planet and say the weather and
all right. Thanks, Adam.
days and years. Yeah, that'll be good.
Cool. So for the first activity, we don't really need to get into too much CDSU, do we?
Not a great deal. So basically, it's just the CDSU. I think we'll need to know the size of the sun, the diameter of the sun.
Yep.
we have the size of the planets just in case.
Cool. Yeah.
That's it. Yeah. The main seed issue is okay. Ready?
Oh, very good.
Oh, is it recording? Oh, dang, sorry. All right, so welcome, welcome to week 5's science planet activities. There are 2 activities for this one, and they're more activities than experiments per se. So we don't really have any variables in this whole thing, as in, yeah. So there's not much to talk about CMS and changing any sort of variables. Yes, we are using fruit, and I guess the size of fruits can change, but other than that, not really sure. I don't think there's too much to it. So what we're going to be doing is we're going to be using fruits. I've got 8 fruits and a bit of a corn to represent the planets in our solar system. Yep, so the question is, how big are things in our solar system? And we're going to predict the size of each planet in relation to these fruits. So I've got a watermelon, a grapefruit, an apple, a large grapefruit. So we're going to turn this down a bit. So grapefruit, watermelon, apple, lime, 2 cherry tomatoes, a blueberry, sort of smaller, and then a peppercorn. Don't know if we can see that there. There. Where is it? There.
Tiny.
Peppercorn. It is tiny. It's going to be a pain. I'm going to lose it on the field. So we've got these 8 fruits and things. And basically, we're going to label these what we think is what each planet is represented by, and yeah, basically line them up in the order we think they are in relation to the sun, and basically compare the size of the sun and to the fruits, and try and extrapolate what size these things might be. Sorry, that's my face. Okie dokie. So the first thing we can look at, though, having said there's not much to do, predictions. Now that we know what we're doing roughly, do we predict, so the size of each, oh gosh, what are we going to predict?
Wow.
That's a great question.
Yeah.
What are we predicting? The size,
The
how
only
big?
prediction we would do is like what planet is.
It's not a cut later, just keep recording, but, or we can just discuss this. What do we think the prediction's going to be? So we can sort of, it doesn't have to be, I think, like an initial hypothesis or anything. I think it's just what we think we're going to see, or how. That's it. Yeah.
Yeah.
Yeah, we'll probably get some wrong.
I think it will be, it's not quite a prediction, but like you can start forming ideas of whether the planets will have different sizes depending on how far away they are, or different. So it's not quite a prediction, but you might be thinking about it as we're going through.
Yeah, absolutely. I think, yeah, I think this is more like pose a question, do the activity, answer the question kind of thing, more than anything.
Yeah.
But, all right.
Yeah.
So we're happy to move on from that, like, instead of trying to create some prediction. So health and safety things for this one, I will take some notes here. Health and safety, obviously, I think don't eat it. You know, we've got fruit. Kids can bite into the apples and that. They bite into the peppercorn. That won't be good. That was the obvious one.
Sarah, by the way.
Pardon?
Something's wrong with you. We can't hear you, Sarah.
Sorry.
Yeah.
I had it off. I was gonna say, for a health and safety, what you read would be obviously for the eating, but if you know, everyone's hands touching it and like germs, you know, COVID or a virus or
Yep.
can get quite dirty. Or,
Of germs, good hygiene practices.
Yep.
So would this be a more demonstration where students are watching the teacher rather than where each student has all this food in front of them, or each group has all these food in front of them?
Do it in groups, have their own little discussions about it all.
I think.
Will they all have food in front of them?
you could do either or, I reckon.
They could just come up to the front of the classroom and look at it on the table.
Yeah.
It doesn't have to be food. It can be anything. It can be
So these could be replaced.
You could even ask them to bring in their own objects. And do it as a group. So every group has a person brings in 2 objects each.
Yeah.
But just making sure that the sizes are correct.
Yeah. I was going to say, if they did end up having it as a group, you could just have it that they hand sanitize or they use baby wipes or something before they touch it. But then there's still a chance that they could drop the fruit, and then that's like, that could be a tripping hazard, or you have to clean it up. And
So I'll add that one in as well. Tripping hazards. We dropped fruit.
What about like allergies?
Yeah, actually.
That's interesting.
That might be another good reason why the teacher would do it and not every student, just to take it all, the questioning out of it.
Another reason why we could use, it might be, in some ways it might actually be better than, like, rather than a watermelon, which is already expensive and easily breakable, but rather than that, maybe it'd be better something like a basketball, because it's roughly around the same size, but it's perfectly round as well, like, because the cuts aren't actually like oblong, they're not an oval as it is, so it could show a more realistic interpretation.
Substitute the same, well, I guess neutral objects. I suppose you still have the issue, which I was going to say next, of using it as a weapon. So, because this is so heavy, a strong kick, this is heavy, might throw it at another kid or drop it on their own foot, things like that. Whereas a basketball, it still can be thrown, but it might not hurt quite as much as an 8-kilo watermelon.
Yeah.
So that one is.
The basketballs would be good as well for like the school as well, because they would already have them all in like the PE department.
Yeah.
They would go out buying like any watermelons. You could, if you did decide to use watermelons, like just an incentive thing, you could just say like, we'll have some fruit afterwards, or like a morning tea.
Okay. Can we think of other health and safety issues? So the other things being used in this are things like tape measure, ruler, post-it notes.
Actually, tape measures are pretty sharp. You could easily cut yourself on a tape measure.
Okay. Sure.
Maybe you could use one of those like
measuring
like when you measure yourself on your body.
Yeah, the tape.
Those are like
yeah, it's now
I think 30 meters forever.
Oh, except like my school had a
wheels.
That would be good.
Don't
know if every school would have a wheel, but if they did, it's a good option.
Yeah, I mean, you'd hope the PE department might. But anyway, it's an option. Yeah, other than that, when I guess we got allergies, part of this is outdoors, obviously, for the 30-meter activity. Do we need to be mindful of hazards outdoors? So
hats.
Definitely hats.
And then I guess if you're outside, behavior management is more important because it's a bigger area. Kids aren't sort of confined.
Yep. So behavior management, so giving them like
boundaries
and expectations.
Yeah.
This might be more of an extreme case because but like there'll be more risk of allergies as well. Like I had kids in my class who were allergic to grass, or they were just very sensitive to looking like they always needed sunglasses. I know there were different things like they might have to might have to make sure that they're
the grass, ants, bees.
Yeah.
So it might be better
based on what the teacher's knowledge is, because the teacher would know every kid's allergy.
Yes. EpiPens and that.
I was gonna say, yeah, you'd have to take first aid of some kind.
Yeah.
Yeah.
First aid. And then anything else in that, do we think? Health and safety. Well, we might move on from health and safety then, because I feel like that's pretty comprehensive. Sorry. And then moving on from health and safety, understanding activities fully before completing them. You guys understand I've got these post-it notes, and basically I'm going to write, we're going to discuss again what these represent, each one. I'll write the name, we come to a consensus, and then I'll stick it on it. Then we're going to pretend the same thing, and we're going to line them up.
Are those our ideas of them that you're sticking on there, or are they the real?
They're our ideas. And you know what? We could get it right. Don't you know. All right. Everyone knows their assigned roles.
Yeah.
All right. Let's get started. So, can anyone remember? Oh, and the other thing I wanted to discuss really quickly was: do we think the materials and the procedure needs to be written down for this one, or do you think it's something that doesn't need to be written down? That's one of the questions.
What do you mean written down for the kids?
Step one, do this. Step two, do this. Step three.
You mean for students?
Pardon?
Do you mean for students, like in the classroom setting, like written down for students to read?
Yeah. So if they were doing this as a sort of experiment, do they need the step-by-step direction procedure?
I guess it would depend if you're doing it as a
I think
I think it would benefit because then they know what's coming up, and you know, some kids that struggle with, they just struggle with time management, or like they feel comfortable knowing a process. They might just feel more comfortable if they can see exactly what's happening throughout the activity.
Yeah. Would their procedure look a little bit different though? Would it? Because let's say they're not doing it. Would it be more of an observation thing to observe or label the planets, then put in the order you think they should be in, and then write down your observations, something like that. You know what I mean? Rather than what the teacher might have to be a little bit more full on, a little bit more detailed.
Yeah.
Well, I still think there'd be a procedure, surely.
Yeah.
I think it could probably just be like as a class we'll discuss this and we'll all do this. So it sounds very inclusive, but then we're like, and the teacher will move it to the right part.
I reckon we could even make it a game. So I don't even know what we agreed on. So it was like the teacher had the objects, right? Or was it each group had it? What was the actual thing?
Drop that, Nathan.
We said.
I think we didn't mind both, but I was going to say...
Yeah, we talked about that, both could work. I think...
one would come just the teacher. It could be a game where, a group of however many kids, 5 or 6 kids, in the group would come up one by one and play and sort out whatever they think in order, and then do their own observational data and predictions and hypotheses and everything. So every group will be different. So there's no clues or there's no real teaching at the start. Or it's think, and then towards the end, obviously the teacher will teach the CDSU side.
Yeah.
And then the kids will be like,
I suppose that stops kids getting influenced. doesn't it? It's distinctions and things like that, the ones that just call out which. Having said that, let's get started. The facilitator asked if anyone can remember a mnemonic. So does anyone know a mnemonic for the planet, the order of the planets? You know what a mnemonic? So like, you know that every good boy deserves fruit for the music?
No, I don't remember it.
I remember being taught one. I just can't remember it.
Yeah, I know
And
that
when we were
was.
taught, there were 9 planets.
Yeah. Now Pluto is no longer on it, right?
Yeah.
Yeah, so Pluto's not. So I've only got 8 things here,
Cool.
guys. So yeah, cool. Thank you, Katie. Keep that in mind. I do know a mnemonic, but I don't know if that's not okay for me to say or not.
Can we hear it?
Oh yeah, actually, I'll tell you. Can I?
I think
mean,
it could be
Yeah.
I think it would be fine.
I've got the answer. Like I already know what the answer is because of that facilitated document.
Yeah.
But I knew the mnemonic before I saw the facilitated document.
You can,
I'm in such a precarious position. Alright, I will give you the mnemonic if no one else can remember it. So, my very elderly mother just served up nachos.
I think I've heard something very similar. That's a good one.
Yeah, so I'll say it again. My very elderly mother just served up nachos.
We got this.
Oh, we got this. All right. So what I'll do is we've got all the fruits in a group here. I'm just going to move this back a bit. Further back. There we go. Which do you want to start with? You just tell me. Do we want to start with the big old one, the smallest one, the apple, the lime? What do we think would be easiest?
Go from the biggest.
Yeah,
Biggest?
biggest because then we to the smallest maybe.
What do you think the biggest is?
I reckon it's Jupiter.
I reckon it's Jupiter.
Yeah, Jupiter probably pretty good. I think it. I don't know. Like Mars is pretty big though.
Mars is pretty.
Jupiter or Mars? Jupiter or Mars? I mean.
Mars is smaller than Earth.
Really? I was thought it was bigger.
I think so. I don't
Oh,
know.
idiot, dude.
Pardon?
It's all good. Yeah. What do we've got? Nathan and Katie still.
Jupiter, maybe?
Jupiter.
I don't know,
Mars,
because it's
Jupiter.
just so much bigger than all the other fruit there.
Okay. Actually, okay. How about this? An easier way to do this might be. Does everyone know the names of all the planets?
Yeah.
Mercury.
Alright. Name the planet. Do we want to start with Earth? Everyone knows Earth.
That'd be a good idea.
Why don't we go, because we don't know the, why don't we go from the smallest to the biggest, because then we can do the,
Yeah, I mean, that's the other thing that we could talk about here is there's so many different ways to approach this.
Yeah.
We can, you guys are going to start with the smallest one, the peppercorn, and tell me which planet you think it is. We're going to, oh no, actually, sorry, it does say write the names on the paper notes first, so I've got to write all the names out. So we do that, then we label it, and then I suppose after that, it's deciding, do we label them, do we start with the name, do we start with the sizes, you know, what do people who know the sizes might go, I know like the smallest one's that one, or something like that, you know, or the biggest one's that one, so they'll be jumping at opportunities rather than go, and you might want them to just, all right, we're starting with Mercury, or we're starting with Saturn, you know, and going. Okay, so back to the mnemonic. Sorry about that. We're going to write. I'm going to write all the names on these post-it notes. What do the things stand for? Can everyone remember? Well, we know Earth, right? Like that's that's a gimme. So Earth.
And then Jupiter.
Jupiter.
Mars.
Someone said Mars.
Mercury.
We did hear Mercury come up.
Venus.
Mercury. Say Neptune, was it?
Neptune.
Yeah. Yep.
Venus.
Venus.
There's Uranus as well. How many is that?
Then there's Saturn.
Yeah, I think Saturn's also.
Wait, very close. 1, 2, 3, 4, 5, 6, 7, and you said Saturn makes 8. Right. So I've got 8 post-its in front of me. All back here, sorry. The screen can only handle so much. How do we think is a nice way to start this? Because it doesn't necessarily have to be in the correct order, like labeled in the correct order.
I think if we do the correct order, then we can kind of get a judgment of the sizes.
Ordering them comes next, so after we label them.
Yeah, we're supposed to order them.
Using your previous knowledge on what sizes you might think.
Yeah.
If we bought in order, we could actually get that phase done first, so we all have like an understanding, so we can see all of our point of views of the order as well.
What do you mean?
As in, you want to order the post-it notes?
We could do it by order of the planet, and then we can do that phase now.
I think that's what the sheet says. The sheet says, choose an end that represents the sun one at a time as a group. Discuss which fruit relates to the first planet and why, and you continue on doing that.
Also, it kind of sounds like it is ordering it first. Like,
Yeah.
But how do we know? So we're ordering it based on the size of the fruit, not the name of the planet.
Well, yeah, then we can put the name on the side of the fruit that we think, maybe.
Right. Okay. Yep. I see what you're saying now. So this we'll call the sun.
Yep.
So it's over here. I'll put it on the edge of the screen so I can actually fit everything in here. So I've got the sun. I'll get more in if I go from back here. I've got the sun here. So we're going to go this way.
Yep.
What do we think comes next? So we've got
I guess would be Mercury.
Mercury, and I think it would be kind of small.
I've got a few small ones. I've got 2 cherry tomatoes up here, a blueberry, and a peppercorn.
We'd start off with the smallest, wouldn't we? For the peppercorn.
Do we think Mercury is the smallest?
Be closer to the sun, wouldn't it?
Well, I thought
It
it
is
was
close to the sun.
Mercury or Mars, but I'm not too sure which one's smaller.
I thought it was, I guess, yeah, I was going to say,
You don't have to have prior knowledge. Like if you know the answer, that's not a terrible thing. But you have to tell me why.
Well, what do we know of warm-based planets versus cold planets? Because that'll be the sun. Because Mercury is a hot planet, right? Is Mars a hot planet? It is, isn't it?
Yeah.
So Mars will be close to the sun, and then Earth.
We don't know the temperature of the planets. So maybe Earth.
I said Earth would be in the middle.
Okay, yeah.
Roughly. Because it's,
I heard Nathan before say Mercury is close to the sun,
Yeah.
and it's little for that reason.
Mhm.
And you're sort of saying it's hot. It's a hot planet.
yeah.
So I presume that means you're saying it's close to the sun.
Yeah. I thought maybe it'd be easier to order them maybe if we knew which ones were hot or cold. Neptune's hot,
Yeah.
so Neptune would be pretty far away. Isn't it?
I don't know.
Because I'm going off a
Sounds
past
reasonable.
ago knowledge.
I reckon that's why the mnemonic thing comes in,
Mm.
Yep.
where
So
where
it's
it helps.
my
It might-
very elderly mother. Yeah. So it's one of the M planets.
Yeah.
So
Well, I think
Mars or
it's
Mercury.
It's Mercury.
Mercury.
No fun. All right. So I'll put Mercury down. So I got my Mercury. Oh, goodness me. I've stuck it. There's Mercury. I'm putting it next to this one. Or next to this one. Okay. My very
Venus.
elderly mother. Yeah. There's only one big ass. It's Venus. But here's the real question: which one's Venus?
Maybe the.
Like the apple?
The apple?
I don't know. That was just because I know it's not the biggest one and it's not the smallest one, and there's only 3 medium-sized fruits, which is the lime, the apple, and the grapefruit. And I'm like,
We still have cherry tomatoes.
Yeah, I was going to
And the
say
blueberry.
Berries, a blueberry. The grapefruit, just so you know, in Australia, well, you can see it is larger than the apple.
yeah.
Are the cherry tomatoes the same size?
The cherry tomatoes are the same size.
I think it could possibly be just a cherry tomato because I think I think there are other bigger planets that are
Yeah.
colder.
Oh. So you're saying the closer they are to the sun, the smaller they are.
No, I'm just going off my understanding that there were a few big cold ones.
Because then the one
Kind of
furthest
big.
away would be the biggest, right? Thinking that way.
Not necessarily. I was thinking that there were a few that were still, I don't necessarily know that. I was just saying there are a few I know that are still bigger and they're further away. I don't know if that's based on anything, it's just they're further away.
That's fair enough, yeah. So, we're saying it's not this one. You don't think it's a larger one, meaning these ones?
Yeah, I don't think it's going to be them.
So we're down to 2 cherry tomatoes, a lime, and a blueberry. Just have a crack, guys.
Just a cherry tomato.
Yeah.
Cherry tomato?
Yeah.
Oh, we can't hear you, Nathan.
Sorry, I agreed. Cherry tomato.
Oh, yep. I definitely thought you were just pulling faces. These guys are idiots. I know what the answer is. Alright, so Venus is a cherry tomato going next to Mercury. My very elderly.
Earth.
E.
Earth.
Yeah. That's the one. Third rock from the sun. Earth. Which one's Earth, guys?
I don't know.
Could it be a lime or is that too big, do we think?
Yeah, I was thinking lime or cherry tomato.
Mm.
It's not blueberry because I know something smaller than Earth. Mars is smaller.
Ah, okay. That's cool. Yeah.
Yeah, I'm pretty sure.
Well, that cuts that one out.
It's either
Not
cherry
too much
tomato
more, is it?
or lime, but I don't know about all the other planets.
Well, we don't think it's this one
No.
because you guys said this. You were talking about this one before, and you don't think it's the blueberry, so it's one of these ones. It's still close to the sun. And if we go off Victoria's thinking, it'll be one of the smaller ones. So it's cherry, tomato, or lime? Just have a guess.
I think it could be the lime.
Feeling the lime?
I want to say lime, yeah.
Yeah,
Okay.
just say lime.
Okay.
Because
I got
it's like
lots of
small,
nods.
but it's not big.
Yeah.
Beauty. Lots of nods, lots of limes. Putting next to Venus, my very elderly mother.
Mars.
1M. Mars. Yes. Elon Musk's second home.
That one's tiny, so that's got to be the blueberry.
Mars is tiny. Yeah.
From what I remember.
Yep. We lost Nathan. But keep going. Mars is tiny is what we feel.
And we chose
But this is also smaller than Earth.
So like the gas planet, so E.
So Nathan, yeah, we're looking. We've decided that Mars is next, and it is smaller than Earth. So we've got a blueberry and a cherry tomato. That is smaller than the lime.
I'd go probably the blueberry.
Feeling the blueberry. Sarah was also feeling the blueberry.
I'm feeling the blueberry.
I would go to the blueberry.
Everyone else?
Yeah.
Yeah.
Alright, get on. Blueberry. My very only mother, just.
Jupiter.
Jupiter, folks. Which one's Jupiter, do we think? We've got 1, 2, 3, 4.
The biggest one.
The biggest one?
I think so. That's what I remember.
Victoria.
Yeah, no, that sounds about right.
Alright. Nathan, down with that being yeah. Katie's.
Yeah.
Alright. Oh. Ah, damn it. Alright. My very elderly mother just served.
Saturn.
Saturn. Yes. And is this how you do it with students, do you think? You'd sort of like use the mnemonic every time, one at a time?
Yeah.
I think they'd like that.
There will be no thinking involved if you don't, I think. I think it would just be a guessing game constantly.
Mm.
Yeah.
We're teaching them the numeric as well if you do that. So that's
Yeah,
good.
that's true.
Do it every time. It's repetitive learning.
Yeah, I
Yeah.
suppose that's good point. Go. Sorry to you.
You can see how much we're struggling and we have how many years behind us of supposed to have been prior knowledge.
Yeah.
So Saturn, all right. Got 3 left.
Grapefruit? Or is it
The what's
smaller?
that?
Again, there's so Saturn, something Neptune served. What was in between?
The one with the ring around it, okay?
Saturn has the rings, yeah.
Has the ring. So it's I remember it being quite big as well.
Yeah.
I used to think it was the biggest, and I got it mixed up. So now I think it's, and then I got to knowing that it's the second biggest.
Yeah.
So,
Second biggest. Okay.
yeah.
Sarah said it's still
I would
quite
say
big.
grapefruit.
Yeah.
The grapefruit, which is the largest one left.
Yeah.
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 I would say.
We have a consensus. We have a majority anyway. All right, grapefruit. You are Saturn. You can go next to him. And served up. Uranus.
Uranus.
We have 2 left, guys.
Yeah, what's the other one? And Neptune.
Neptune is next, yes.
Yeah, what do you reckon the sizes are there?
So one of these
I feel like we may have made a mistake though for how small that planet is, but maybe not. I don't know.
Well, what's smaller?
Is it going to be one of the things that goes up and back down?
Maybe.
What do you think smaller?
I think Neptune would be smaller.
I think Neptune would be smaller as well.
Okay, well,
We're putting this one as Uranus.
yeah.
Alright, let's move it along. Uranus, which makes, man, I'm losing space. So we know this one's here. And Neptune.
Yep.
Alright, so, good stuff. Well done getting through that. So, do I tell you the attribute has been allocated? It's down the line. I guess it's great. Let's take a photo. All stuff ends. Sorry, guys. So I've got a couple of photos of there just to document what we've got. All right. Do we, because we discussed basically why we thought each one was which. We don't have to discuss the distances, only the sizes. Based on what we've got here, do you guys see any sort of a relationship to the sun?
It gets bigger in the middle. It kind of looks like this.
Like the way we've got it, yeah, it's kind of doing that. Except for Mars, that sort of like drops down and then going up. These would, I guess, these would be observations and discussions you could have with students. I'm about to tell you the correct proportions. So which one's where the label should go. And let's do it. Mercury was the peppercorn, so we got that right. Good stuff. Yes, was the cherry tomato, so that was good as well. Well done. The Earth, however, is the same size as Venus, apparently, or at least it's also a cherry. It's a cherry tomato as well. So Earth is a cherry tomato too. So I'm guessing it's quite similar to Venus. All right, and then Mars was the blueberry.
Yeah.
Well done. That was Sarah's prior knowledge coming in as well. There. Jupiter is indeed the watermelon. Big thing. Saturn was the grapefruit. So nice job, guys. Well done. Your prior knowledge is holding up. Uranus was the apple, which leaves the lime for Neptune.
We got one.
Yeah.
Yeah, that's pretty much it. Just the one. So what do we see now? I guess is the real thing. Like, what does anything surprise you about how this all looks? How this has landed? This peppercorn is flying.
It kind of makes the progression from Jupiter has a more steady slope rather than straight to a cherry tomato has.
I'm guessing.
Yeah, they're both. It's more like a triangle, even though one's just it's kind of like you know, an irregular triangle. You know, like one side's very small.
Yeah.
It's a lot bigger.
Yeah. If it wasn't for Mars, it'd be pretty neat, wouldn't it? But I think it says, well, what I'm seeing is like what Nathan said at the beginning. This is annoying. I'm gonna have to squat down. These ones are really small, right? Like, so we've got this sun here, which, to give you the size of the sun, what do you guys think? How big do you think the sun is? Like, are we talking the size of another watermelon, or bigger, smaller?
Well, it's not that. Isn't it? I did know how many Earths fit into the sun, so it's bigger than the Earth. That's for sure. I don't think it's bigger than Jupiter. I don't think
it's not.
From my understanding, actually, I'll let you guys go because it's easier. I think it is primary. I'll let you guys go.
It's smaller. I'm pretty sure it's smaller than Saturn too.
Yeah. Does anyone else have anything to add to the size of the sun?
I always just thought it was really big.
Yeah.
Like, no, with relation to other planets, just big.
Yeah.
So,
yeah.
I don't
So the sun
know.
is.
I thought it might be like the size of another Lime roughly. That was my kind of
Another
guess.
Neptune.
Yeah, roughly.
Well, I think what might be easiest here is now if we get the CDSU on the size of the sun.
Right.
Can
Well,
you give us an analogy or something, or something that'll help us?
Yeah. Well, because all the planets are going around orbit, they need to be in a gravitational pull. So the sun needs to be really, really big for our solar system to go around the sun.
Yep.
It needs to have that much gravity to keep it in orbit. So the sun is very, very big to keep those planets there.
Yep.
It's not really proportional to the planets. Well, it is proportional. I mean, it's much bigger. You'd have to do a very, very large piece of fruit.
So to give you an indication, we're going to use these fruits for the next activity, and the sun is going to be represented by a 2 meter a bed sheet that's 2 meters in diameter.
Wow. Yeah. So
that's like, well, that's taller than me.
Just to give you an actual the radius of the sun is 700,000 kilometers, and the radius of Earth is 6.3.
Oh. Yeah. So that's a lot. Yes, I was completely wrong.
It's massive. It's constantly growing. And it's interesting, I think, that such a massive thing, all the planets that we think and know are closer, they're so much smaller. Like they're just tiny. So I don't know what the implications of that are. I don't know if we can have any insights just from that. But it's pretty obvious how small that. The other thing I guess to consider would be how far away is this? Jupiter.
Yeah.
That it's so much bigger. Yeah. What's going on there? Like, is there a big gap between the distance of Mars and Jupiter, and so Jupiter from the Sun? That's what we're doing in the next activity. That's what we're looking at. But that might be something to infer from this. So the question at the beginning was, how big are things in our solar system? So we know the sun is this monstrous, massive thing, right? And Mercury, right next to it, is this peppercorn. So yeah, I don't know if you can imagine 2 meters right now, but you chuck that peppercorn on a 2 meter space, 2 meter circle. That's that's nothing really, isn't it? It's so tiny. And I guess that's what we're trying to develop. That's what we would be trying to develop in the students, isn't it? A visual representation of the solar system, but also a general idea and picture of the massive difference in sizes.
Yep.
Proportional size. Because obviously this is not exact. Fruits are different sizes. So this isn't the biggest watermelon. Actually, it is the biggest watermelon I can take that I saw, but I'm sure there's bigger watermelons than this. So that's something that might affect things as well. So it's not exact, but it gives them an idea, doesn't it?
Yeah.
What I'm going to do now is take a photo of this. Delora, do you want to discuss the data that we can take from this? Because this is the end of the first activity.
Yep.
Data people, is there what kind of data we can take from this? Or?
Guess you could just do a graph.
While it's all just sitting there, do you think we could measure the size, like just the diameter of each thing? Because it might be easier while it's sitting there rather than out when it's all being measured by the big tape measure.
Would that be accurate though? It's still a fruit.
Yeah, no, it's just roughly, because then you still get, it's supposed to be a rough representation.
Yeah.
Of the thing.
How much? So basically, roughly, we're looking at, and this isn't super great, let's say a diameter of 21.5 centimeters for Jupiter.
Mm-hmm.
So I'll start with Jupiter, then I'll know about water. Ready? Yep, sorry. Mercury, the peppercorn, is 0.5 millimeters.
Yep.
Well, that would be centimeters.
Venus,
Centimeters.
0.5 centimeters, yeah. And the cherry tomato is 3 centimeters.
Yep.
The other cherry tomato is also 3 centimeters. That worked out. The blueberry is 1.5. So it's half the size, I think. And I don't know if that checks out. Do we want to do the CD of the size?
You want to do that, Nathan?
Fun facts.
You didn't do grapefruit or apple or lime.
Yeah.
So grapefruit is 9 centimeters.
9.
Yep.
Yep.
And the apple is 7 centimeters. And 5.5 for Neptune, the lime.
Yep.
Thank you.
Thank you.
No worries. So, yes, I guess we can put those numbers.
So I kind of started, it's not done or anything because I was just waiting on all that data, but I can quickly screen share kind of what I've started, and maybe you can give me some ideas if that would be okay.
Yeah.
One second, sorry. This hopefully this will work. If not, I'll put it on. Ready? Can you see that?
Yep.
While that's happening, I might ask a couple of questions. What year level do we think this will sort of relate to in the Australian curriculum?
3?
But
I don't know, 3?
Yeah, I think it is pretty basic. I think a grade 3 can do it. What was that, Victoria?
Well, I remember just learning this kind of stuff in year 6, and then we moved on in year 7 to the shadows of the moon and everything on the shadows of this Earth onto the moon, and vice versa. So I think it actually might be higher. Like, I mean, it could be used either way, but I just remember doing it higher up in higher grades.
In on the Australian curriculum website, they have for year 5 the Earth and its place in the Earth Sciences one, Earth, the solar system, or something like that.
Yep.
So I can relate to that, and then I guess because you're throwing around such big numbers and proportions and things like, and those maths concepts, I think the older they are, upper primary might be more manageable for them.
Yeah, and
You know what I mean?
they would be able to understand how big something would be as well, easier, right? So that could come into it. Like, they wouldn't have such a hard time.
That's what it is. They can sabotage that sort of stuff. So
Yeah.
as they're older, yeah. So that's where I would think it would go. How would we don't have the well.
I think it might be because you're sharing your.
Okay. All right. Well, I'll turn it off, but that's kind of just where it started. But I was also thinking, we're not actually really looking at the sizes, and we didn't predict the sizes. I was thinking, should I just do more of like a simple, what do you call it, a pie chart graph?
Like a pie chart in terms of like what would be the things in there?
So because I think this first activity is pretty simple. It's not actually really looking at our predictions in the size.
Yeah, I wouldn't make a pie chart only because that sort of suggests they're all part of a whole.
Yeah.
If you know what I mean.
Yeah.
And like a fraction, but they're not. They're just being their own thing in the solar system. So the bar graph, if we are going to do something like that, I think a bar graph would go further.
Okay.
Yeah. I was thinking while you're saying that it might make sense to do that, because then the pie chart could just represent the solar system. But then just forget the idea that there's like a lot of space involved in that solar system. Correct. Maybe.
Is everyone else struggling with their audio? Like, I'm getting some weird feedback stuff and I can't understand anything. Is it better now?
Maybe we'll just turn off our mics until we're actually speaking.
Yeah,
That might stop feedback.
And I think Victoria's frozen for me. Unless she just stopped. Oh no, she just stopped moving. Alright. No problem. Diverse learners. How do we think this activity could cater for that? Cater for diverse learners?
It's nice and hands-on. That's
I
good
think
for engagement.
it is very hands-on, but putting it in the hands of the students.
Very visual.
Yeah.
Yeah. So nice, simple visual representations. It doesn't require as much for, say, what do you call it, hearing impaired students.
I guess you could have issues with communication if they're doing it in their little groups and they have to discuss among themselves and decide where they go. There could be issues there.
Yep. Yeah, absolutely. I think for a visually impaired student, this might be rough.
Yeah.
And to be honest, maybe you get ill.
But they could also
Yeah.
feel the size.
Feel
And that might be the. Yeah, no, so I think I guess for a visually impaired student, you might do the touch thing, just have them go, okay, wow, this is massive.
Yeah.
I guess it can be made. I mean, there's all those interactive apps and things like that. It can be made more engaging for some, like say a student with ASD or something just wasn't having it, and you found a way to the app. If you have them on that app on the iPad that shows you each planet and how big and how many of each fit in each one, kind of thing, that could be a way to engage them.
Yeah.
Yeah. Well, I think that's as far as we're getting for that one. For this round, how would we assess this activity? I guess it's through the science notebook. So what I'm about to do is write down some observations. So I was just going to write down how we noticed the planets closer to the sun are much smaller. The biggest is in the middle, and the smaller ones are at the back end. So that's what we sort of observed. Yeah, and they get progressively smaller as they get further away after the peak in the middle. We observed that Venus and Earth are the same size. Mercury is the smallest. Mars is the second smallest, and Jupiter is the largest. So those were sort of like the standout ones, I guess. So all those observations would be written in a science notebook or journal.
I think participation would be a really big one as well. Because, like, it's all based on how much input everyone puts in for as well. How much input they're like, oh no, I think this would go here because of this, or no, what about that? Like, if they just sit there and do nothing, then part of the participation.
Part of their observations could be drawing at the end as well, where they put everything.
Yeah.
And then
actually going through and drawing
the graphs and stuff they develop.
Yeah, so the graphs they make up. So all that would go into that notebook, and I guess understanding it would be, again, this could be done individually or as a group, couldn't it? And if it was done individually and they wrote their own predictions and things and observations, then we know what they do understand and what they do know.
Yeah.
And what they've taken from it. So I think that's good. And then there's one more question. Sorry, guys. I'll explain the CDSU. So, do one of you boys want to quickly go through the sizes of the planets? Not necessarily the distances. Just the size.
Yeah, I won't give away too much, but I have a little sentence here about more of the arrangement of the planets and how they have typical kind of each planet will have something that you'll be able to recognize, like their the size, their mass, their temperature, and these all have to do with the arrangement from the sun. So the first 4 planets from the sun, Mercury, Venus, Earth, and Mars, are known as terrestrial planets, and they're predominantly small and have a rocky composition. The outer 4 planets, Jupiter, Saturn, Uranus, and Neptune, they're known as giant planets and are typically high in hydrogen, ices, and gases. And so all of the planets have characteristics depending on where it sits in the solar system, basically, compared to the sun.
That affects their sizes.
Yeah, so it has that explains the wide range of sizes, compositions, temperatures, and some planets even having huge weather patterns and active volcanoes, and it's crazy.
Okay, well, don't go into that too much, because we'll go into that stuff in the next one. But just quickly, so you said these last 4, the outer 4 are gas planets, or more gassy, was it?
Well, they're typically high in hydrogen, ices, and gases, according to the Department of Astronomy.
So you know how back in chemistry it was gases spread, and they try to fill large I'm wondering if that's part of why they're so big, or so much bigger, is because they just take up as much space as possible. Yeah.
Yeah, much more. Yeah.
Cool. And does anyone else have anything else to add? Because otherwise, that's it for this activity, I think. So I said my observations before. Everyone happy with that?
Yeah.
Did I miss anything? No. We'll have our results labeled and we'll the right-hand side. I think, do we want to discuss the left-hand side right at the very end after the second activity as well?
Yeah, that's right.
Because I think it'd incorporate just our whole understanding at the end, right?
Yeah, beauty. Awesome. So, thank you for activity 1. That is finished. The next activity, let's just dive straight into it.